today we're kind of going to shift gears. We're going to talk about writing and graphing equations of lines. We're going to start with some vocab. Hopefully this stuff is familiar to you from Algebra 1. Maybe if you're in Algebra 2, you've already started seeing some of this stuff. But just some basic line vocab. Number 1, we're going to start off with is slope. When I talk about the slope of a line, it refers to the ratio of its vertical change over its horizontal change. A lot of the times we see this written as rise over run. We've heard that before, yes. And then we have an equation. If I have 2 points, in order to find the slope between 2 points. Those 2 points would look something like x1, y1, and x2, y2. And if I have 2 points like that, I can set it into this equation here for slope. y2 minus y1 over x2 minus y1. x2 minus x1. The letter that we often see associated with slope is an M. I'm not entirely sure why it's an M, but it's an M. And then we have different equations, different forms of writing equations. The most common one that we see, and probably the one that we're most familiar with, is the slope-intercept form of an equation. It literally tells you in the name exactly the parts that make it up. The equation is y equals mx plus b, where m represents that slope that we just talked about, and b represents the y-intercept. Again, I don't know why b is the y-intercept, it just is. That's like the most common form that we see. A lot of the times on our homework, on our quizzes, on our tests, you're going to be asked to leave your final answer in slope-intercept form. So maybe we start in a different form, but we'll usually end up in slope-intercept form. The next form that we're going to see is standard form. We don't use standard form all that often. It's not one of my favorites, but it is this form, ax plus by equals c, where a, b, and c are real numbers, aka they are integers. I'm going to put that note in here, actually. Oops, integers. What does that mean to be an integer? Do we know what integer means? Integer is a whole number, so our numbers are never going to be fractions if they are integers. And then the other rule is that a and b are both not 0. Okay, so that's standard form. We don't use it a whole ton, but it's got those 2 rules that we need to look out for. The last form, is one that we use quite often. It is point-slope form. Again, it tells us in the name exactly what it consists of. It consists of a point and a slope. It takes the form y minus y1 equals m times x minus x1. There are 2 things that we plug into point-slope form, of course. Number 1 is the slope, m. That's what you think. And then the other part is a point. If I have a point that looks like x1, comma, y1, I plug that in here and there. The only 2 things that never change in this equation are the first y and the first x. Those will always be a y and an x, nothing filled in. Any questions on those 3 forms? We'll use them. Point-slope form we use a lot. Slope-intercept form we use a lot. We have 2 special cases, horizontal and vertical lines. Hopefully we kind of remember this. There is an acronym that helps us remember horizontal versus vertical lines. If you think about it's like kind of a nonsense acronym, to be honest. HOI is our first acronym for horizontal lines. The H stands for horizontal, of course. The O, or the 0, tells me that my slope is 0. If I think about why the slope of a horizontal line is 0, if I think about this as my horizontal line, and if I think about slope as rise over run, well, it doesn't rise at all. It's not going up or down, so my rise would be 0. My run here in a line that's horizontal, it goes side to side a lot. And we know that any number, or 0 over any number, is just 0. So that's why my slope is 0. The last part of this equation, the y, stands for y equals, because my equation of a horizontal line will always start with y equals something. And if we think about what the points are, if I picked any point on that line, the y value will always be the same as the number in that equation. On the opposite side is vertical lines. My little acronym for vertical lines is VUX. Again, doesn't mean anything, it's just a little acronym. The V stands for vertical. The U stands for my slope being undefined. Can I squeeze it in there? Yes. So if I think again about rise over run of a vertical line going up or down, it rises a lot, but it doesn't go side to side at all. So I would say that my run is 0. We know that we can't divide by 0, so anything over 0 is going to be undefined. That is how we get my slope is undefined. And then lastly, my equation for a vertical line will always look like x equals. So for example, if x equals 3, any point that we pick on that line will have an x value of 3. Any questions on those two special cases? Okay, so let's talk about what the problems we're going to see today look like. In these examples, we are going to write an equation of a line with a slope of 3/2 that passes through the point 1/3, -2. We are always going to end up in slope-intercept form. We might not start in slope-intercept form, but that's where we're going to end. And if I take a look at my problem, it should actually tell me exactly what form I want to start in. If I have a slope and a point, and I look at my 3 forms of an equation, I don't have a slope and an intercept. I have a slope and a point. So I'm going to start in point-slope form, right? Pretty straightforward there. So number 1, we're going to start in point-slope form. Point-slope form takes the form y minus y1 equals m times x minus x1. And we basically just have a lot of stuff that we're going to plug in here. I know that my slope is 3/2, and I have this point 1/3 comma -2. I'm going to label that as x1, y1. The first y and the first x always stay the same. So I have y minus, y1 is a -2, so I'm actually going to change that to a +2, equals my slope, 3/2, times, that first x always stays the same, minus x1, which is 1/3. That's kind of it for that part of the equation. If it said leave your equation in point-slope form, we'd be done. But we unfortunately have to get this into slope-intercept form, which is y equals mx plus b. How are we going to do that? Any ideas? Dahlia? Yeah, we're going to distribute. We're going to solve for y. So step 2 here, get it into slope-intercept form by solving for y. So I'm first going to distribute this 3/2. Y plus 2 equals 3/2 x minus 1/2. I'm going to subtract 2 from both sides. That's going to give me, I don't want an equal sign, I want an arrow. It's going to give me y equals 3/2 x minus 2.5. I'm just going to say minus 5/2. That's it. Any questions on that? Okay. In the next one, now I have 2 points. I still kind of want to follow that same pattern. 95% of the time, you're going to start in point-slope form. How am I going to find the slope? If I have 2 points, how do I find the slope of 2 points? Do we have an equation maybe? Like right on the top of our page that tells us how to find the slope of 2 points? So if I don't have the slope, my first step is find the slope. Our equation, m equals y2 minus y1 over x2 minus x1. I'm going to label my 2 points, x1, y1, x2, y2, just to keep it all together. So I have 9 minus 5 over -4 minus -3, so plus 3 really. So my slope is -4. We are all here, yeah, we agree. And then we just repeat, just what we did in that last problem. We're going to start in point slope form. We're going to end up in slope intercept form. So let's start by taking that slope, taking our point. It doesn't matter which point we pick. I'm just going to pick the first one. Y minus y1 is 5 equals our slope -4 times x minus -3, which becomes a plus 3. Always finish it off by solving for y. We're going to distribute. And we're going to add 5. Any questions on that? We see the process here. Find a slope, find a point, point slope form, then slope intercept form to finish it off. Any questions? Okay, I'm going to do something different now. Go ahead and flip it over. Number 3 says, write this equation in standard form. Standard form, not one of my favorites, but we still have to know how to do it. I'm going to write it at the top of our page just so we have a little refresher. Standard form takes the form ax plus by equals c. And we have 2 rules that we need to follow. Number 1, a, b, and c are integers. That means they have to be whole numbers. And number 2, a and b are non-zero. Those are my rules for standard form. So if I take a look at this equation in number 3, y equals -4/3 x plus 5, the first thing that I want to do is move my x and y to the same side. I'm going to do that by adding 4/3 x to both sides. So I have 4/3 x plus y equals 5. How am I going to make this equation fit my 2 rules now? They're both non-zero, that's good. How do I make those 2 numbers, a and b, both integers? Do we know? How am I going to get rid of that fraction? Gabby? Yeah, if I multiply everything by 3, I'm going to get rid of that 4/3. So if I multiply everything by 3, I get 4x plus 3y equals 15, and that's standard form. Do we see what we just did there? Okay, fantastic. Now, standard form doesn't really do much for me in the context of this geometry right now that we're doing, especially when I take a look at that and I want to graph it. I can't really graph it by just looking at it, but there is a form that I can look at and graph really easily. What is that form? What form is really graphable? Casper? Yeah, slope-intercept form is really easy for us to graph. So if I say graph the equation in 2 different ways, one of those 2 ways is going to be slope-intercept form. To get an equation into slope-intercept form, just like we were doing on the last page, all we do is solve for y. So I'm going to subtract 2x from both sides here to get negative 3y equals negative 2x plus 6. I'm going to divide everything by negative 3. And now I'm in slope-intercept form. From slope-intercept form, we graph our intercept, y-intercept, and our slope to graph us some more points. So that looks like it's going to go at negative 2 for my y-intercept. Use my slope, rise over run to go up 2 over 3, up 2 over 3, up 2 over 3, up 2 over 3. We can change our slope to go backwards too if we need more. 2/3 is the same as negative 2 over negative 3. So I can go down 2, backwards 3, down 2, backwards 3, down 2, backwards 3, until I've got enough points to kind of cover my graph here. Questions on that? We think we're all able to do that? Okay, let me show you a second way, which you will have to use on your homework, but I'm going to tell you right now, you don't necessarily need to remember it for your test. The second method that we can do, which some people really like, is you can find the intercepts. Intercepts. Can I fit it on here? Sure. So we have two intercepts. We have an x-intercept and we have a y-intercept. The y-intercept falls on this line right here, and we know that its x value is what? If that's on that line, what's the x value of that y-intercept? If it's right in the middle, right here, that x value is 0, right? Can I say the same thing about the x-intercept? At the x-intercept, what's the y value? Also 0, right? So if I plug 0 into my equation for x and then for y, I can figure out the two intercepts pretty easily. So let's make a little table here. X values, y values. Let's start with that y-intercept. I know that x is going to be 0. I'm going to pick a different color. I know that x is going to be 0. So then I take my equation, 2x minus 3y equals 6, and I plug in 0 for x to get that negative 3y equals 6, or y equals negative 2. So that is my y-intercept at 0, negative 2. Hey, look, that's in the same spot that it was on the other graph. So that's awesome. I'm going to do the same thing for my x-intercept. Except this time I know that my y value is 0. So I plug in 2x minus 3 times 0 equals 6. 2x equals 6, or x equals 3. So I get a second point at 3, 0 right here. To graph a line, we need a minimum of 2 points, which I've got right here. We're going to do our best to make that look pretty, like so. Two different methods. This one you don't necessarily need for your test, but it does ask you to do it on your homework. Any questions? Okay, let's look at the weird cases. Graph x equals 5. What does that look like on my graph? What is x equal 5? This way, right, Caitlin? It's going to be a Is it going to be horizontal? It's not going to be horizontal. X equals 5? Think about my acronym. V-U-X. Vux, vertical. Vertical lines go up and down through x equals 5. So through this point where 5 is, right here. Up and down. Undefined slope, x equals. So then y equals negative 1. That's my other acronym, HOI, for horizontal. at y equals -1 right here. Good? Any questions on that? What time is it? I'll quickly talk about this one. Okay, look at number 6. If I wanted to graph this line, I could probably do it right from there, right? Do I need to switch this into slope-intercept form necessarily? How could I start this? Where would my first point go? Is that a hand? Yeah, go ahead. We don't need to do more work than we have to do. We already have a point in this equation. What point is in that equation? Do we see it? I don't want to do more work. This is point-slope form, right? So there's already a point right here. What is that point? The x value is, if this is x minus x1, we have to be careful about our signs, right? So the x value is going to be -3. This is y minus y1, so my y value is 2. So without even doing any work, if I'm already in point-slope form, I can use that point. I can use my slope. Where did it just go? And I can graph it like that. So -3, 2, slope of 1. Look how easy that was. Don't do more work than you have to do. Any questions on that?